Hello everyone, welcome to the second pre-recorded video. In this video we're going to go over a couple problems from chapter 3. Two specifically, we're going to go over 3.5 and 3.6. This chapter, the main concept of this chapter is trigonometry, and that's specifically trigonometry with right triangles. So for problem 3.5, we're given a subdivision lot that looks like the following. And we're told that the angle from here to here is 120 degrees. And the height of this is 200 meters. And the length from this point to this point is 300 meters. And what we're asked to do is find the area of the triangle portion of the lot. So find this missing area. So how are we going to do this? We're going to redraw this triangle specifically like this. Actually, let me make this a little bigger. And we know that the angle right here is 30 degrees. And the reason we know that is because we know from here to here is a 90-degree angle. So the distance between this has to be 120 minus the 90 degrees. That gives us 30. And so when solving this, we know that we have two known variables. We have the known angle right here, and we know the height, because the height will be equivalent to this side, which is 200 meters. And we know the angle. Now, based on the fundamental equations of sine, cosine, and tangent associated with right triangles itself, we can find the lengths of any of the missing sides as long as we have one length and one angle. We have an angle here, and we can label these variables or these lengths by h. We'll call that the hypotenuse, or the largest side. We'll call this O, the opposite, or the opposite side of the angle known, and A, which is adjacent, or the adjacent side with respect to the angle. So the same side of the angle is going to be the adjacent. The side opposite, and not the hypotenuse, we're going to label as opposite. And the largest length is the hypotenuse. And this we have to remember is a right triangle. So in order to do this, in order to find the area, which is what we want to find, we need to know the area of the triangle, which is 1/2 base times height. I don't want to get confused with the hypothesis or hypotenuse. Sorry. So we know that the area of a right triangle, or a triangle in general, is 1/2 base times height. We have the height, which we know is 200 meters, but now we have to find the opposite angle. So in order to do this, or in order to solve this, what we can do is we know that the cosine of 30 degrees is equal to the adjacent over the hypotenuse. Or I'm sorry, yeah, the adjacent over the hypotenuse. So A over H. And we know this, so we know that A is equal to 200 over H. So in order to find H, what we're going to do is just some basic algebraic manipulation. We're going to bring the H over to the other side, and we're going to bring the cosine over to this side, so that we have H is equal to 200 divided by the cosine of 30 degrees. The answer of this is H is equal to 230.9 meters. However, this only gives us the hypotenuse, and what we want to find is the opposite side, right here. So now what can we do? In order to do this, we need to use sine. So we know that the sine of 30 degrees is equal to the opposite side divided by the hypotenuse side. Because we know the hypotenuse right here, we can now solve for the opposite side. So O is going to be equal to the 230.9 multiplied by the sine of 30 degrees. Don't get this confused with 0. This is an O. And the answer to this, the opposite side, is equal to 115.5 meters. So we have the opposite side and we have the adjacent side, or the base and height. So in order to find the area of this, what we're now going to do is 1/2 times our base times our height. So this is equal to 1/2 times the base, which is the opposite side, or the 115.5, times the height, which we know is 200 meters. This gives us our area, so our area is equal to 48,453 meters squared. So using the basic formulas of trigonometry, we're able to find the subdivision of this lot just by giving the angle and one length. And we can apply this for all right triangles. So now let's move on to problem 3.6. Alright, so problem 3.6 gives us the following graphics. It gives us a laser, and it's saying that this laser has a beam that's directed at a pinhole, or a small hole in the circle shown above. So that's very poorly drawn. So here's the center of the circle, and that still stinks. So, but we're given the following triangle right here. And it asks us to find the angle. This angle we'll call alpha, given the distance from here to the center of the circle, or not the hypotenuse, but the distance from here to here, or the x-axis, and the y-axis, the distance to the center of the circle. And the distance is 1.73 meters, and the distance from the laser beam to the center of the circle is 5 meters. Now, very similar to what we've done before, we're going to use the properties of trigonometry in order to find this angle. So we can redraw this triangle now to look like this. We'll have this as 1.73 meters, and this is 5 meters. And we want to find this angle, alpha. So what can we do to find this angle? Now, we know from trigonometry properties that the tangent of that angle is equal to the opposite side, which will be this side right here, opposite over the adjacent side. So now how are we going to find this? We have these two known values. We have the opposite and the adjacent, which is the 1.73 meters, and the adjacent side, which is 5 meters. In order to find this angle now, we're going to do the inverse tangent, which is noted by that, inverse tangent of 1.73 meters over 5 meters. I'm sorry, let me rewrite this. We're going to have alpha equal to the inverse tangent of 1.73 meters over 5 meters. And this is equal to 19.09 degrees. We could also do this a couple ways by finding h, or the hypotenuse side, by maybe doing Pythagorean's theorem by taking h being equal to h equal to the square root of 1.73 squared plus 5 squared, and this will give us whatever h is. And then from this we can also apply sine of alpha, or the inverse sine or the inverse cosine. And just to reinforce that concept, let's just draw a general right triangle. And we'll call this angle alpha. Now we can remember that, and if this is alpha, this is the opposite, this is the adjacent side, and this is the hypotenuse. So we can remember that a little saying is SOHCAHTOA. So, which will be opposite over hypotenuse, SOHCAHTOA. So this so represents sine, so that the sine of alpha is equal to the opposite side, or the O, over the hypotenuse. And the cosine of alpha is equal to the adjacent side divided by the hypotenuse. And the tangent of the angle alpha is equal to the opposite side over the adjacent side. So that if we wanted to find the angle itself using sine, this would be the inverse sine of the opposite over the hypotenuse, and this, if we're doing cosine, will be the inverse cosine of the adjacent over the hypotenuse, and that the angle alpha in terms of tangent would be the inverse tangent of the opposite over the adjacent. This pretty much summarizes the first two problems. We'll go over more of these trigonometry functions and problems in recitation this week. Thank you, and bye.